All right. Hello, everybody. In this lecture, we will try to build our own tokenizer that we will eventually be using for our own transformer system. So all of the code will be living inside this repository. So I guess the very first thing that we will be doing is just some basic information about the folder structures. So the tokenizer, this contains all necessary implementations the about our tokenizer that we will eventually be using for our own transformers. So okay, here we go. So I've already got some text file downloaded from the internet, which happens to be William Shakespeare's As You Like It, and as you can see, it's quite a huge file in relative terms. Obviously not in terms of the huge data sets that large language models are actually trained, but it's, as we can see, 7,457 lines, and we'll try to use this to build our own tokenizer. So let's go. We don't need to save it. We'll save the readme and we'll go here. So first we definitely need to build up the vocabulary. So transformer models do not really understand text per se, because they do not really understand what is going on. They, like every other program, they understand numbers. So the first thing that we will be trying to build is a system that converts words into numbers. A tokenizer is essentially a program that tokenizes text, which is converts words into certain numerical identities, which can then be fed into a transformer, and a transformer will use these representations, numerical tokens, for further processing. So let's dive right into it. Okay, so the very first thing that we really need to do is we'll first assume that well oops so assumption, so we'll be doing it in phases. So we'll first go with the assumption 1, which is the model is a character level language model. All right, so the very first thing that we will try to do is build a system, or build a vocabulary build a vocabulary for this. So let's define a function. Let's say def vocab, and in here, so already we see that in the same folder structure, in the same hierarchy, we already have a copy of the text file. So what we will do is we will extract all of the unique characters from the text file. So how do you do it? So let's build something called char is a, let's say, open text file, and we'll be reading it. Now once we have read it, this will be a list, so we will use the set function to sort of extract the unique characters from this entire list, and then we'll be converting this into a list. All right, and we'll be sorting the list. So essentially what is happening here is we are opening a text file in a read-only mode. We are using a set operation to sort of extract the unique letters, and then we are sort of converting that into a list, and then we are just sort of sorting it out. So let's see what happens here. So let's print this thing. Okay, so let's run it. Okay, oh, my bad. So what does vocab return? So we see that it gives us a list of the vocabulary as a list. So what we will do is we'll just return this, and we'll just save this as a object called vocabulary. We will print the vocabulary, and we'll also estimate the length of the vocabulary. All right. So as you can see, this entire text file, William Shakespeare's As You Like It has got 94 unique characters, and the sorting operation has sort of, as you can see, you have some unique characters here. Then you have all of the numbers, and then you have some more special characters, and then you have got all the letters, so A to Z, and then well, interesting. So we see that there is no capital Z in this text, which is very interesting, and we have all of these small cases here, the letters, and then we have some more special characters, and there are 94 such characters. So alright, okay, the next thing that we have to do is somehow create a function to convert letters to indices, which is what we kind of want. So we'll define a new function called, let's say, string to index, and it will take in vocab as the object, and what we are after is to okay, so okay, how do we, okay, so should we return it this way? Let's see. So return, okay, so what do we want to do? We want to sort of return a dictionary that has indices for I in vocab, right? Okay, sorry. So I comma v and v. Okay, let me just write this function, and then we will just see what this function does. So this will be I to s, and let's just make these modifications here, and let's see what happens. So essentially what we're trying to do is let's just print s to I and I to s. All right. Okay. Oops. What did we do? Where did we go wrong? Okay, never mind. So what we will do is, we do not need it as a function, but we will just sort of yeah. Okay. Oh, oops. Oh, okay, yeah. So now let us see if this works. Where did we go wrong? Okay, so we have the v2i, okay, my bad. So I didn't initialize the vocabulary here. Okay, let's see. This should work now. Yes. So essentially what we're doing is, for every vocabulary element, we are mapping the vocabulary element to a number, and we are kind of converting a number to the vocabulary element. So these are just the two functions. Now let's try to create an encoder that will encode, that is, convert the strings into numbers. So how do we do that? So let's say we define a function lambda, let's say s, right. Okay, so what does s do? That is interesting. Okay, so what it does is it converts every voc every vocabulary item to oh, okay, my bad. So what we will do is s2i. Okay, let's change the name. I'm sorry. So string to index, and we have index to string. All right, so this will be less confusing for me and for you. So what it does is it's a string to index, it's got vocab as the vocabulary, and I to s is index to string, and then you have got the vocabulary. So these are initialized, we have got them as objects. So now what we are doing is um, mm, okay, sorry. So now we want the mapping to sort of map the characters to numbers. So let's say C for C in S, alright, and we'll just copy this, we'll make it decoder, lambda, let's say D, and it'll be I to S for C in D. All right. Well, just let's make it E and D. Okay. All right. So let's see if this works. So we need to have encoder for this works. All right. Let's see. And I kind of need to. Okay. So oops, okay, interesting. So right now, as we can see, the encoder, which is here, it just sort of converts all of these strings into numbers, and the decoder is doing the reverse mapping, and which is it's mapping the numbers into a character. All right, now there's obviously one part that we kind of hate here, so we don't like the format here. So what we'll do is we'll just join them, and yes, I guess. Oops, my keyboard seems I'm continuously pressing Alt and Tab, and so I'm just opening up other windows. Alright, so let's see what we have here. So in less than 20 lines of code, we have already, okay, we'll just comment these things out. Yeah, okay, no need to comment out. So within like 20 lines of code already, we are looking at how a transformer transforms text into numbers and the opposite. So this is the structure of a very basic encoder decoder and a very basic example of tokenization. In the next module, we will be talking about how to have a system that actually learns how to do not character level splitting but byte level splitting, and we would also discuss why do we need such a system. So until next class, this is what we have.